Got my first Soundcraftsmen probably a few years ago, and it sounded so sweet I couldn't stop listening to it. And then I found I had to have another one, and another one. Pretty soon the need to have them just consumed me and started to take over my life. And I buy them in any condition and bring them over to Ray to have them fixed. And I have them sitting around my house, but I just can't stop buying more and more of them. And I don't know what to do when I get the last one. But whatever you do, don't buy a Soundcraftsman.
Hi folks, so I've got yet another Soundcraftsman here from my buddy Steve. I don't know where he finds them all, but if you can't find a Soundcraftsman, it could be because you bought the last ones. This one's got meters like the one I worked on previous to the video I put up on the 5002A. This is an MA5002, no A suffix. So this has regular analog meters on the front. If you recall the previous one I had worked on that had meters like this, both the meters were destroyed. I assumed it was dropped. It looked like it had been stored in a bad location, a lot of moisture, etc. So this one, I had shot some video previously, don't know where it went, but that's why the cover's already off, and it's firing off into a dead short. The power supplies on these will stop and restart, a lot like switch modes that go into tick-tick mode when they encounter a short. So I'm going to show you what it does, and then we're going to dive in and see what the problem is. Okay, so when I turn this on, you'll see that it cycles. See how it blinks? And if you look over the dim bulb, it does the same thing. A little hard to see around the hot air station, but so yeah, it's firing into a short, and I just need to find out where that is. Good news is I see the meters jump a little bit when it does it, so at least it looks like the meters are good. Before I dig in here, I just want to talk a little bit about this circuit. Now, the last Soundcraftsman I did was the MA5002A. This is not an A suffix, this is just a 5002, and this guy has quasi-complementary output. So all the output transistors are NPNs, our drivers are NPNs, and then our I guess they're pre-drivers, I'm not sure what you'd call these, but these are where our NPN and PNPs come in. These are Darlingtons. So this may be a triple Darlington design. I'm really not that good with that kind of thing. But I'm pretty sure we probably have some shorted outputs. So I'll show you how I dig around in these. Previously I tried to check from the output to the collectors, but these outputs tie right to the collectors, so that wasn't a good approach. So I'm just going to show you how I go about finding out where the problem is, because it's usually one channel or the other. Very rarely is it both channels. Okay, so I got one probe and extender so I can dig down in here and find an emitter or collector. So let's see, I got the Darlington on this end. They don't seem to go, so we got our Darlington driver, our outputs are the last two on this side. So I'm just going to go to the collector, which is the case on the TO3 transistor. And I don't have any shorts here. Normal diode drop. Should be the same here. These guys are completely paralleled, so just check one, you're good. Now on this side, I believe the orientation is opposite. So these are going to be my outputs. These two on this end. And that looks okay. I think this channel's okay. So I'm going to go over to this channel. And let's see here. That side looks good. Okay, and then we go down to this channel, and let me see where our, okay, so the last two here are our outputs. Boy, it's hard to get down into these. There's our problem. One or both of these outputs are shorted. So I'm going to pull these out, we'll check them and see what the problem is, see if these are the only problem. Okay, so I did find a short. It was not one of the outputs as I originally thought, but it was the driver here. And once I pulled it out and checked it, I'll show you, I'll check it on camera with the meter. But this cleared the short. It was interesting because I pulled these two out, they were okay. And then I looked at the pins on the sockets that were left. I still have my short, that's what pointed me back to here. And I don't know how many of you have watched a lot of my videos, but usually when you got a dead short in an amplifier or it's stuck in protection, you know, 99 times out of 100, you got shorted outputs. The amp might have been driven too hard, poor ventilation, short on the speaker outputs will blow these things in the blink of an eye. But this is generally where you're going to find your problem. It's going to be in your output stage and it's going to be your output devices. Most of the time, this is the trouble. Sometimes when you have a dead short and your fuse is blown and it turns black, and I believe I've shown you this, well, I don't know where it is at the moment, but when you have a fuse whose element has just exploded, you have a dead short. Occasionally, you'll have a shorted filter capacitor in the power supply, maybe shorted diode in the bridge rectifier. Most of the time, in stereo power amps or power amps in general, you're going to have blown outputs. Simple as that. So I'm going to move the camera so you can see the meter, and I'm going to test this, and you'll see where the fault is. Okay, so here's our bad transistor. These are known as TO3 packages. And when you hold them like this with these two leads closer to one side than the other, this is your emitter, this is your base, and the case is the collector. Now since they're NPNs, we're going to check them with the red lead on the base, black lead on the emitter, good transistor, red lead on the base, black lead on the collector, looks like a good transistor. Now we're going to check it emitter to collector, and we have a dead short emitter to collector. There's our problem. So this transistor is bad. Here's another one of the ones I pulled out. And if we check it the same way, okay, red lead on the base, black lead on the emitter, looks good. Red lead still on the base, black lead on the collector, looks good. Emitter to collector, see, that should be open. You should not have a short between the emitter and the collector. That's good. That's bad. Now you'll also see tests like this where you reverse and put the black lead on the base and you shouldn't get anything. And we don't. This one, the bad one, black lead on the base, red lead on the emitter. See, that's not good. Black lead on the base, red lead on the collector, not good. And of course we have our dead short emitter to collector. So this is a bad transistor. I'm just going to replace all the ones there, and then we'll put this thing together and see what it does. And incidentally, these things are a bear to get out. I mean, the ones on this end are okay because you can get to all the screws, but the ones on the inside necessitate lifting up the board here and then trying to get your screwdriver in here. I was using this long bit and it worked okay. But I think I'm going to order one of those flexible tips because I think I'll be able to then snake in under the board and get to these transistors a lot easier. Because these on the inside are a bear to get out. Okay, so I've got the transistors replaced, got it back together, and I tested it off the dim bulb tester, and it does fire up. I also moved from the Variac to a heavy extension cord because big amplifiers cause too much sag on my bench. So, I'm going to turn this thing on. It's an overload, pops out of protection, and I'm going to put a little signal in. Hey, meters work on this one. So let's take a look at the scope and analyzer and see what we can get this thing to put out. I think it's 200 watts a channel. I don't recall for sure. So let's just see here. Zoom it in. Let's try that again. Wow, 277 watts. I think it's just about starting to clip now. Yeah. All right, so this is probably about 250 watts a channel. Okay. This thing's looking good. I'm going to hook some speakers up to it and put some YouTube safe music on. We'll see what we get. All right, let's put something in here and see what we can get. Make these meters dance. Okay, blew the fuses in my speakers. This thing puts out way more than these little bench speakers will take. But anyhow, it's sounding pretty good, looks good, and I'm gonna stop this video right here. I did rough in the bias, and I'm gonna watch it because these things seem to take a long time to settle after you adjust the bias. So I'm gonna keep an eye on that, but our repair is done. I hope you enjoyed watching this video. And as always, I like giving back to the community that's given me so much. Thanks a lot, folks.